Hello. We're going to set up some analog inputs. The equipment that we're using is a PLC from Automation Direct. It's a DL06 with an analog expansion module with 2 analog ins and 2 analog outs. We're also running a GS2 inverter drive, which will be taking the spindle load analog signal and bring it into the PLC to put a load meter on the screen. And the other analog function that we'll be doing is a pot to do feed override and slow jog override. So to start, we'll actually start scripting our macro. To start scripting the macro, the first thing we want to do is get our inputs. To do the inputs, we're going to do spin load, and this is going to be our value that we're reading. To read the value, we need to type get input, and the input is 65. It's the second analog input. The first one is 64, which is actually my pot. And we can do that one right now as well. So feed pot is get input. That's going to be 64. So now that we have our values, we need to do a little bit of work to them. Well, the first thing we need to do is divide them by the range of which the analog value coming in is at. It actually comes in from a range of 0 to 16,533, which is 4,095 in hex if you read their manual. So we're going to divide it by 16,533 and divide by 16,533. Now that I've done that, I've actually got spin load and feed pot, our values ranging from 0 to 1, which is a good number to multiply by because that's basically just a fraction. Hit enter. On this line, we now need to set spin load to the proper value. I could do this inside of the call to set the DRO, but for troubleshooting purposes, this is much better. So spin load equals spin load. So now that we've typed in spin load, the next thing we need to do is start doing our math. So spin load times 100 will give us a value anywhere from 0 to 100. Now the feed pot is going to be a little bit different. This one we want to do slow jog and feed over. Now that we have the slow jog and feed over, we need to do a little bit of math to those. Well, my slow jog, I only ever want to go down to 4, and I'm going to go up to 100, so 100 minus 4 is 96, times feed pot. Now, by doing this, basically what's happening is this range is from 0 to 1 times 96 plus 4 is going to give us a range of values from 4 to 100. And I'm going to do something very similar here. But as low as I ever want to go for my feed override is 10 plus, I only want to go to 125. So rather than the 300 that Mach 3 usually does, I'm going to limit mine. Plus feed pot. And now I've got the values correctly in. I can test them. So I'm going to step into the program. I can see I have basically no spindle load. My feed pot is at 0.39, so it's 39%. And I'm going to turn the feed pot to one extreme. And I can see it's reading 0. I'm going to turn it to the other extreme. And I can see it reads 1. So I know that one's working. And the spindle will try in just a minute. So now that we have everything working as an input, we'd like to set some DROs. So to set a DRO, you need a call, and set DRO for a normal DRO. This would be like for axes numbers and stuff like that. And 21 is the feed override DRO, I believe. Let me just check. Yes, it is. This can be seen on the, if you go into Screen Designer, you can kind of count off which DRO it is. I'll show you that in just a minute. For the normal DRO, for a set DRO, and then the OEM codes are, you can actually see inside the manual. So this one is going to be feed over, and close brackets, and then call set OEM DRO, and this one's going to be 3, comma, and this one's slow jog. Now that we have those, the last one we need to set is the spindle load, but before we do that, I'm going to call the flyout tab, bring this back up, and I'm going to get the pod about in the middle right now, and I'm going to step into the program and see that it's actually at 37%, and we should see the values on the screen change here and here when I finish running this. So 125 and 39. Well, it shouldn't have gone to 125 right off the bat. So we'll bring it down, we'll run it again, go the other way, and we've done something incorrectly. That's because we have a plus right here. So it's a good thing we ran it like this. So I'll change this to a multiply. We'll try that again. Now we're going to step into the program to test and see that it's functioning. I now have it set about halfway. As I step into the program, we can see it goes to 52 and 38%. That's good. So now it's time to set the spindle load. To set spindle load, what we're going to do is go through, and we're going to have to do some Screen Designer work and whatnot, but we need to set a DRO. So we're going to go call set user DRO, and the user DRO that we're going to set is 1045 to the spin load, and we're going to save the macro as the macro pump. Save, yes, and we're going to close Mach 3. We're going to go and edit 1024 screen set. This is the normal screen set that you'll be using in Mach 3. And since I don't actually have anything reading back the RPM, I'm going to change this one to load. And I'm going to change the DRO beside it to 1045. And whether I had that 21 from before for feed over, if you count all the way across, so go across and then down, then across again, down, across, when you get to this, you'll actually be at 21. That's how I figured out what the OEM number was for that. Excuse me, just the plain DRO number was. So I'll hit OK. I'll save it. Close this. Open Mach 3 back up. And I'm going to try and use my analog pot. And we can see that as I turn it, I can go from 100 in my slow jog down to 4, and 10 to 125. And as you can see, it responds fairly well as I turn it. Okay, so now the only thing we have left to test is the spindle load. Well, you're going to want to watch right there. We'll turn on the spindle. And I'm actually going to pull the brake a little bit to see if I can get the load to jump up. And as I apply the brake more and more and more, you can see the spindle load climbing up. I didn't apply it too hard because I didn't want to burn out my brake too much, but we can see that our macro pump's running just fine. So, hope you enjoyed it, and thank you.